Okay, so moving on to comparing two population proportions or two population means, independent case or dependent case. So the first thing you need to do is decide, is it going to be proportion or is it going to be the means? And because it says proportions here, obviously we are comparing two population proportions. Here we are comparing students who think math and science are very important and parents. And let's see if there is a difference. Okay. So first thing first, let's compute the sample proportions. So let's just open up Desmos calculator and let's look at what is the first sample proportion. So that would be students. So this is the total 1,346 students out of 675. Okay, so let's divide the 675 by 1346. Now we have to round this to 4 decimal places, it looks like. So let's go and put that here. Okay, so approximately 50% of students thought math was important. Let's see what about parents. So we have 772 out of 1251. Okay, it does look like there's more parents think that math is important, but we will see if that's statistically significant in a second. Okay, so that's the sample proportion number 2. And remember, of course, that's number of successes divided by the number of trials for each sample. Okay, so the next thing that we do is we're going to actually get to the hypothesis. Now, if you're not sure what to select here, you can have Desmos help you out. So let me just get rid of all this stuff and let's go to the inference menu. And we're going to click on the z-test for proportions because we are comparing proportions. Now we do have two samples. So let's see. For the first sample, which is the students, we had 675 out of 1346. Now let's click on sample 2, which is the parents. We have 772 out of 1251. Okay, entered all of that. Let's click on create test. And let's expand the significance test first. So now you can see the null hypothesis is P1 minus P2 equals 0, which is the same thing as saying that P1 is equal to P2. So this is just equal. And we're going to have the same thing here also, P1 and P2. Okay, so now we have to decide on the sign of the alternative. So choices are not equal for both, less or more. How do we know? Well, this is going to be a little bit more tricky than for just one sample. So let's see how we decide that. Everything really depends on the claim. So it says more parents, right? It says more parents think that math and science are crucial, but what's number 1 and what's number 2? So here is what I would do if I were you. On a piece of paper, I would write, okay, number 1, that's students, because it's going to depend on who is number 1 and who is number 2. Number 2 is parents. Now, if it says, according to the claim, that more parents think that math is more important, this number will be greater. And this would be smaller. So when you draw the inequality, always draw it from the smaller towards the larger. So it opens up like that, right? From smaller to larger. So this is actually going to be a left tail test. Another way you can see that and just double check, because I think it's going to be less than, is look at the test statistic. By the way, the test statistic does not change. If you change the tails, it's still going to be the same. It's the p-value that will change. But the test statistic is negative. So that's another confirmation that this is going to be a left tail test. So let's click on left. Okay, the test statistic, we already see that. It's negative 5.927. The p-value. Now, when it says it's less than 0.0001, that just means it's the tiniest number. So this is just according to like for us, it's just going to be 0. And of course, 0 is less than any other positive numbers. So we are obviously rejecting the null hypothesis. And we do have enough evidence that the proportion of students who think that math is important is less here. Okay, here they've been really tricky because they are trying to make you rephrase the. So when you say that the parents proportion is higher, it's the same thing as saying that student proportion is lower. Okay, so that's plane of words. That's kind of not fair, right? Okay, anyway, let's look at the next part. That is the confidence interval. So let's open up that menu. And for the confidence level, we're going to select 0.9. Okay, so that is already rounded to 3 decimal places, so we can just copy the numbers, and then we are going to start discussing how to interpret. So the interpretation depends on the case. So let me remind you about the cases here. So case number 1, so case 1 is when you get a minus to a plus. So the first number is minus, the second number is plus. This is no statistically significant difference. So I'll just abbreviate it for saving space. So that's no difference. Case 2 is when you got plus plus. This is 1 is larger than 2. So sample 1, whatever that was, is going to be larger than 2. So that's what we're going to say. The same thing is true for the population. And finally, case 3, which I don't have space to write, but case 3 is going to be like minus minus. This is where the second one is larger than the first. Okay, so looking at our cases, this is a minus minus. So the second one is larger than first. But second was what? What? Look at over here. Do you see how number 1 was students and number 2 was parents? So parents supposed to be larger because it's the second one. So look for the choice that says we are 90% confident that the more parents think that math skills are important, and it should also make sense according to what you think should happen, and that would be parents think more important than students.